Okay, here we're going through the questions that were at the end of chapter 34, and I want to make certain you review these because there were a few errors there that I would hope that you'll understand, and the logic and the reasoning for the correct answers on these, because you know that you do sometimes see these on the test. So for both these and the ones from chapters 31 and 33, make certain you've reviewed them for the test as well. The answer to number 1, of course, is A. It's going to appear just like that. And for this number here, you're standing there in front of the mirror, and the image of this, if you're standing over here, the image is going to be right over there at C. So the answer for number 2 is C. Daniel walks directly from the mirror, speed 0.25 meters per second. The speed relative to him is going to be twice that, 0.50 meters per second. So the answer there is C as well. Number 4, a ball is held 1.5 meters in front of the mirror. How far is the image from the ball, from the ball? And answer there is it's this far in front. It's going to be that far in front. The two of them together is going to be D, 3.0 meters. Okay? So which of the following statements is true concerning a convex mirror? And that answer is D. The image will be closer to the mirror than the one produced by the plane mirror in its place. Number 6. Imagine you're sitting in the back row of the classroom. Your instructor is standing in the front with a large convex spherical mirror. What do you see in the mirror as your instructor walks from the front of the room to your location? All the while, the mirror is facing you. And what you're going to see is I see my image right side up, and it gets larger as the mirror approaches. Okay? So here I am walking with that mirror towards you. Your image is going to be right side up, and it's going to get a lot larger as you get closer to you. So the answer there is 6A. 7. Imagine you're sitting there, and now I've got a concave spherical mirror. What's going to happen now? And the answer is C. You see your image initially inverted, then right side up, and it gets larger as the mirror approaches. Number 8. Which of the following best describes the type of image formed when an object is placed between a concave mirror and its focal point? It is virtual, B. Okay, so there's that one table, I think a couple of tables that I had in the chapter that has it laid out, and that would be one thing I would make certain I made a copy of so we understand the relationship of when it's real, when it's virtual, where it is with respect to the focal point and the center of curvature. Number 9. Which of the following best describes the type of image formed when an object is placed at a distance greater than the focal point? And that would be A. It is real. Number 10. Which of the following best describes the type of image formed when an object is placed between a convex mirror and its focal point? Now it is B. Virtual. 11. An object is placed at the center of curvature of a concave spherical mirror. What describes it? And the answer for this one is inverted, same size, real, B. Number 12. An object is placed to the right of a spherical mirror that is concave towards the object. The object is at the focal point of the mirror. Which of the following is the best description? And the answer is E. No image is formed in this situation, right? No image is formed. 13. While shopping at the grocery store, you look at a convex security mirror. You'll notice that your image is 1/4 of your height. By estimating your distance to be 2 meters in front of the mirror, determine the focal length of the mirror. And that's just a simple application there, and that works out to be A, 0.67 meters. Okay, you should know that equation. Consider a strange device placed at the center of a curvature of a concave spherical mirror shown in the drawing. The focal length of the mirror is 5 centimeters. The device has 2 light bulbs, but the lower one happens to be burned out. What will happen when the upper light is turned on? And the answer there is C. The lit bulb's image will appear inverted at the same location as the unlit bulb, so the unlit bulb will look like it's turned on. 15. Parallel rays of red light are redirected at a converging lens at a focus point P through the central axis. Okay, it's surrounded in air. If the lens is surrounded in water instead, where will the red parallel rays be focused? Okay, and the answer is D. It will be to the right of the point P. Okay, so it's going to be to the right of that. A knight from a chess set is placed at the focal point of a diverging lens, as shown. By carefully constructing a ray diagram, determine where the image of the knight will appear. And again, you're using that same type of thing. And here, it turns out the answer is E. It's going to be the image is at a distance f/2 to the left of the lens, but it's upright. Okay? So the answer is E for that one. 17. The knight from the chess set is placed at the focal length of a converging lens. By carefully constructing a ray diagram, now determine what happens here. And because it's a converging lens, and this is at the focal point, no image is formed. No image is formed. The answer is A. An object is placed at a distance 2f, 2 times the focal length, to the left of a converging lens with a focal length f. Using the thin lens equation and the magnification equation, determine the location and magnification. Okay? So for 18, the answer here is D. The image is formed at a distance 2f to the right of the lens, and it has a magnification of -1. Make certain you understand how to utilize that and why that is the correct answer. 19. An object is distance 5.0 to the left of a converging lens with a focal length 2.5 centimeters. Again, thin lens equation and magnification equation determine the configuration of everything there. And the answer is D again. Image is formed 5 centimeters to the right of the lens, and it has a magnification of -1. Okay? 20. Which of the following phrases best describes images formed by diverging lenses? And that is D. They're always virtual. 21. A physics student desires to create a beam of light that consists of parallel rays. Which one of the following arrangements would allow her to accomplish this task? Again, they try to get females in there, and that's the only way they can do that. But anyway, 21, the answer is C. The light bulb is placed at the focal point of the converging lens. Okay, focal point of a converging lens. That's how you get that coherent beam of light, or parallel beam of light. 22, a compound microscope described in the text is made up of 2 lenses. Which of the following statements is true concerning the operation of this microscope? And the answer is D. The lens closest to the object forms a real image. The other lens forms a virtual image. I think they actually had this exact wording in the text somewhere. In her biology class, Chris examines an insect wing under a compound microscope that has an objective lens with a focal length of 0.70 centimeters, eyepiece focal length of 3.0 centimeters, lens separation distance of 16 centimeters. Chris has a near point distance of 22.5 centimeters. What is the approximate angular magnification, that's theta sub m, of the microscope as Chris views the insect wing? That theta sub m equation should lead you to this number right here, -140. And the final one, which of the following statements best explains why chromatic aberration occurs in lenses but not in mirrors? And the answer is E. Different colors of light are refracted by different amounts of light as it passes through the lens. Okay? That's the reason. You don't have the refraction when you have the mirror there, right? That's just reflection. So the answer is E there, and that answers all those different questions. Please refer to your text if you have a question, or you can email me as well. But do review those and the ones at the ends of the presentations for chapters 31 and 33 so that you do extremely well on this test, just like you did the last time. Let me know if there's any questions, and that's it for now.